Alright, welcome to section 10.1. We're going to talk about graphing sine and cosine equations in this section, but actually this entire unit is about graphing trig functions, sine, cosine, tangent, and we're even going to get into those reciprocal trig functions and those inverse trig functions. So let's get our pencils ready. We're going to start graphing. So in terms of graphing these sine and cosine graphs, they are always going to look like waves. So we're going to have these pretty kind of tranquil waves going on in our graphs when we go ahead and graph some of these sine and cosine equations. But more particularly, they are called sinusoids. Okay, that's how you say that funny looking word right there. So whenever you have a graph that's kind of repetitive, we have this nice easygoing wave motion, they're called sinusoids. Just like a U-shaped graph is called a parabola, a wave-shaped graph is called a sinusoid. Now, since sine and cosine graphs look like waves, there's a lot of different applications where sine and cosine graphs are actually useful, such as kind of denoting sound waves or light waves, trying to visualize a sound wave or a light wave graphically. We can talk about springs, pendulums, microwaves, ocean waves, earthquakes, anything that kind of has a repetitive motion to it, where it's kind of going in a circle or almost repeating itself. We can use a sine or cosine graph to model these different types of applications. So let's get our pencils ready, and we're going to dive into these waves. Alright, so if we're going to graph these cosine and sine equations, let's go ahead and first develop a table of values. If we can get a table of values, it should be really easy for us to plot these points on a graph. So this is when a unit circle is so handy. Okay, we should be really familiar with the unit circle after the last unit. So here's a little refresher of our unit circle. Again, remember that the cosine value of a particular angle is always kind of the first one written, almost an x value. And then the sine is the y value. So what we're going to do, since we're going to be graphing these different exact values, these ordered pairs here, let's try to find ones that are really nice, really easy to graph. So for instance, we might not want to graph the square root of 2 over 2 or the square root of 3 over 2. Those can be some pretty ugly decimals like we found in the last section, like 0.707 or that 0.866. Let's try to focus on easy values. So we're going to focus on angle measures or radian measures of 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Because if you take a look at those ordered pairs, notice how we're either dealing with a value of 0 or we're dealing with a value of 1 of some sort. So those are our pretty easy ordered pairs. Let's just take a look at cosine. If our angle measure was 0 radians, okay, cosine is always the first one written. So when we have a measure of 0 radians, we would have a cosine measurement of 1. If we have an angle measure of pi over 2 radians, we would have a cosine measure of 0. If we were to go over to pi, our cosine would be negative 1. If we were to go to 3 pi over 2, our cosine would be 0. And if we were to do a complete revolution, okay, 2 pi radians, we're all the way back at 1 again. So notice how those are really easy values. We can definitely plot 1 and 0 and negative 1 on a graph. Now if we were to check out the sines, again, let's start with a radian degree or a radian measure of 0. This time we're going to focus on the second value, which would be 0. If we were to check out pi over 2, we would have 1. Pi would give us 0. 3 pi over 2 would give us negative 1. And a full revolution, a complete 2 pi, we would be back at 0. So now that we have these ordered pairs, let's go ahead and take a look at what they would look like graphically. So let's go ahead and take a look at maybe our cosine graph first. These are going to be called parent functions or parent graphs. You may remember this phrase or this kind of vocabulary word back from the beginning of the year when we were talking about transformations. Okay, since we're graphing, we're going to bring back all those different transformations that we talked about at the beginning of the year. Moving things left or right, up and down. Maybe we are reflecting them somehow, like kind of flipping them over an axis, or maybe we're even stretching expanding them or shrinking them. So since this unit is all about graphing, we kind of need to refresh our memory on those different transformations. Left, right, up, down, reflections, and even those stretches and shrinks. I know that you guys love those so much. Okay, so let's go ahead and take a look at cosine first. Notice how our x values are dealing with radians. So our x-axis should be labeled in radians. We're going to go from, it looks like 0 to 2 pi. So that's going to be our x-axis. And normally we're going to count by pi over 4s, or in other words, quarters. So here's 1/4, here's a half, here's 3/4, and then here's 1. So in terms of radians, we got to make sure we have those pi's in there. So let's graph this. 0, 1 would be somewhere right there. 2 pi, 0, pi, -1, 3 pi over 2, 0, and then 2 pi, 1. So remember, these graphs should look like waves. So when we connect these dots, we're not going to be, it's not going to be a V shape. It's not going to be jagged edges. We're going to have nice, smooth curves, just like a wave. Now remember, this is a repetitive motion. If we wanted to, on the unit circle, we could go around again. So if we were to do maybe another one, we would have pi over 2, and then if we were to go another pi, or sorry, 2 pi, and then another pi over 2, we could repeat this pattern. So just because this is one section of our table, okay, we only focus on these values, we could imagine that this pattern would repeat itself, just like a wave does. So really, I mean, we could imagine this going more this way, and, well, actually going back up like that, and then we could imagine this piece going in that direction as well. But we're really just going to focus on, oh, I didn't mean to do that much. I wonder if I can go back somehow. There we go. So we're really only going to focus on this particular section, because this is one full revolution. That's all we're going to focus on. But really, you can imagine it continuing in the other directions. So let's take a look at kind of some important aspects of this cosine graph. Notice where it starts. Okay, on the x-axis, it's starting at 0, 1, but in terms of a wave, this is called a max. It's a high point. And notice, and as we go on, we hit a min, and then we're kind of back at the max again. So a cosine graph always starts at 0, 1, which is considered a maximum. Now let's check out sine. If we were to graph 0, 0, pi over 2, 1, pi, 0, 3 pi over 2, -1, and then a complete revolution, we're kind of back to where we started. So again, wave-like motion, no jagged edges, nice smooth curves. So we take a look at sine. This one actually starts at the origin. And it's not really a max or a min, it's kind of in the middle. So we're going to say it's what I call a baseline. Notice how that this point goes right through the middle of your graph. Okay, it's not a max, it's not a min, it's kind of right in the middle. So it always starts at 0, 0, or in other words, that baseline. Alright, so now that we know what the sine and cosine graphs look like, we're going to talk about different characteristics that could actually show up in these sine and cosine graphs. So the first first characteristic that could show up is what's called an amplitude. And the amplitude is the maximum displacement, or in other words, a distance moved by a point on a vibrating body or wave. So after all, these are waves, and it's measured from its equilibrium position. In other words, I called that the baseline. So notice how if we were to focus on our sine graph right here, if the baseline goes through the middle of the wave, okay, in this case it's the x-axis, this piece right here is the distance from the baseline. Okay, notice how we're at the middle of our baseline and it looks like we reach a height of 1. So in our standard equations, the amplitude is always the number kind of being multiplied out front. That's telling you how high your sine or cosine graph is going to be stretched. Notice how this is a vertical stretch. It's being multiplied in front of, on the outside of our equation. So both of these, sine and cosine, if we were to do this one as well, would both have an amplitude of 1. Now it's an absolute value. Okay, we're taking just the number itself, because sometimes we might have like -2 cosine of x. In this case, the amplitude is just 2, but the negative, remember, is bringing in that idea of a reflection. Okay, we're going to see those in this lesson as well. So the negative is a reflection, but the 2 would be considered the amplitude. It would have a height of 2. So maybe we'll say this is 2 up here. Really, it would look something like this, a height of 2. Now, something else we can talk about is the period, or in other words, a cycle. This is the change in x values required for the function to complete one full cycle, or in other words, one full revolution. So if we were to take a look at our sine graph, okay, notice how we start at the origin, and if we were to trace this wave, this curve, it would take us 2 pi until we're back to where we started. Okay, this is one full cycle. Because notice how if I were to continue, I would repeat the process. So one full cycle in this case is 2 pi. But sometimes our equations might be changed a little bit. We might have, for instance, sine of 2x. Okay, so in this case, this is considered that horizontal stretch or shrink. The verticals change our vertical height, but the horizontals, we're kind of stretching or shrinking our graph horizontally. So to find our period, we're simply going to take whatever this value is of b and divide it by this 2 pi. So 2 pi divided by b is going to give us our new period. How long is it going to take our graph to do one full cycle? Maybe we'll change the sine, for instance, the cosine. Notice how the cosine period is 2 pi as well. Okay, we go from a maximum and then we hit another max right there. That's one full cycle. We're kind of back to where we started. But sometimes we can have a period of pi. What if I were to do something like this? Notice how I'm shrinking in my graph. Okay, so from maximum to maximum, it only took me a distance of pi instead of 2 pi. We're going to be stretching and shrinking our graphs. Now the last one is frequency. This is just the reciprocal of the period, and this kind of tells you the number of cycles the graph completes in the given interval. So we would say in this case, one full cycle is completed in pi radians. So this is basically what's referred to as a rate of change. How often or how fast something is changing, how long it takes for it to change. So when we're going through some of these problems, especially in the application sections, you might see something like cycles per minute. This is a rate of change. So whenever you see something like this, it's referring back to the frequency. And again, notice how this letter B is always related back to our standard equations. It's that number being multiplied by the x on the inside. Alright, so before we go ahead and try our first example of graphing these sine and cosine graphs, just a little heads up, you are not going to be able to use a graphing calculator on the mastery check. I know you want to, okay, you can use it when you're doing the practice problems because it's a wonderful tool to check your work, but just a heads up, you're not going to be able to use one of these on the mastery check. So we really need to know how to do this by hand. We really need to know how to analyze these equations so that we can graph them. So let's take a look at our first example here. We have y equals 3 sine of 2x. So what we're going to do is first identify maybe the amplitude and the period and the frequency, and then based on that information we're going to graph it and talk about the x-intercepts and the maxes and mins. So just as a little refresher, I'm hoping we kind of remember the RST shortcut that we kind of went over at the beginning of the year when we were talking about transformations. We always start with the original, okay, or in other words, the parent graph, and then we go through this motion of transformations to graph it. We always start with the reflection first, okay, that's what the R is for. But then we go into the stretches and shrinks. And in terms of sine and cosine graphs, all these trig functions, the stretches and shrinks are the different amplitude and period changes. So these are the stretches and shrinks that we're going to focus on first. So stretches and shrinks. And then we're going to talk about those translations. Are we moving them up or down or left or right at all? In this lesson, we're just going to be moving some items up and down. Actually, the next lesson, we're going to get into how we move them left and right. So this one should be pretty easy, just moving them up and down. So let's take a look at our first example. The 3 is the A value, which is our amplitude. And then the B value based on our equation is 2. Now to find the period, how long one cycle is going to take, we simply take 2 pi, because normally that's what a regular period is for a sine and a cosine graph. But this B value is 2. So we're simply going to take a regular period of 2 pi divided by 2, and our new period is pi. So instead of going from the origin all the way to 2 pi, we're going to shrink it from the origin just to a regular pi. Now the frequency is just the reciprocal of the period, so that would be 1 over pi. So this is telling us one cycle should be completed in pi radians. So let's go ahead and start with our original first. Sine always begins at the origin, and then at 2 pi we have a max. Pi, we're at an x-intercept. 3 pi over 2, we're at -1, and 2 pi, we're back at the beginning. Notice how everything's kind of evenly spaced out. Okay, we go 2 units and then we have a max, 2 units and then we have an x-intercept, 2 units and we have a min, 2 units and then we have another x-intercept. So everything seems pretty evenly spaced. Even when we stretch and shrink and move these transformations left, right, up, or down, they're still going to be evenly spaced. So we don't have a reflection. Notice how we don't have a negative sign. So let's go ahead and talk about our period. Okay, this time we want a period of pi. So instead of this ending point being at 2 pi, we now want it to end at pi. So what I'm going to do is use a different color. Okay, you might have to use some colored pencils or different colored pens to help you out with this. But instead of the whole first period ending at 2 pi, we want it to end at just 1 pi. It's still starting at the origin. Okay, sine always starts at the origin, but instead of ending on 2 pi, it now has to end on pi. But if our original graph was evenly spaced, it still has to be evenly spaced between these 2 points. So notice how in the middle of our original we had an x-intercept. So in the middle of our red dots we need another x-intercept. That would be somewhere right there. Now if we were to look at the blue graph, from the origin to pi we had a max that was right in the middle. But now notice how in between this red dot and our middle red dot, we still need a max that's in the middle. So we're going to put one right there. And if we look at our blue graph, from pi to 2 pi, directly in the middle we had a min. So now for our new frequency, or our new period rather, from this dot to this one, we still need a min that's in the middle, somewhere right there. So if we were to connect those dots, there is our new sine graph, but just with a period of pi. Notice how we do one full cycle, and it only takes us pi radians to get there. Okay, you can still imagine that it's going to go like a wave, but we're just going to focus on our first piece. So if you want to, you can erase the blue graph, but if you like to see the different colors just to see your steps, go ahead and leave it there. So let's cross off period. And now we'll try our amplitude. So now let's focus on the red graph. Instead of having an amplitude of 3, an amplitude of 1, we need an amplitude of 3. So this distance, instead of being 1, it now has to be 3. So we're going to move this point, instead of a height of 1, we're going to move it up to 3. And same with this one. Instead of having a height of 1, it now needs to have a height of 3. So we're going to go up, down, and then back up again. Alright, so we can cross off amplitude, that one's done. And notice how we're not adding or subtracting anything on the ends, so we don't have to move anything up or down. So the green graph is actually our final picture. Now, since this is the final, let's go ahead and fill in what the rest of the waves would look like. So if we were to continue this pattern, okay, if we were just to repeat this cycle over again, we would have another max up there, and then an x-intercept, and then a min, another x-intercept, and then a max. So we can repeat the process, because remember these sines, they're never ever going to, or these waves rather, they're never going to stop. So if we can go in the other direction, fill in the rest of our graph. So there is our final sine graph. Alright, so let's go ahead and analyze our x-intercepts, maxes, and mins. So if we take a look at our first x-intercept, okay, other than the origin, our first one is at pi over 2. But notice how we have a lot of x-intercepts. We have pi over 2, we have pi, we have 3 pi over 2, we have 2 pi, and actually since our sinusoid is going to continue in either direction, we're going to have an infinite number of x-intercepts. So let's make sure we denote that with this starting value. So we start at pi over 2, but to get from our first x-intercept to our next x-intercept, it looks like we travel a distance of pi over 2. Because after all, if we start at pi over 2 and we get to pi, that's another pi over 2 distance. And that's actually the same distance for each x-intercept. So depending on how many times you want to add this pi over 2, okay, we can use an integer to denote how many times we want to add it, you're eventually going to land on an x-intercept. We can do the same thing for the maxes and the mins. Okay, so our first max is occurring here at pi over 4. But notice how to get to our next max, we travel a distance of pi, or in other words, 1, 2, 3 tick mark, or sorry, 1, 2, 3, 4 tick marks, which is essentially 1, 2, 3, 4, that's pi units. So we can take our first max in this case, add how long it takes us to get to the next one, but depending on how many times you want to add that distance of pi, you're going to eventually land on another max. So we can use that integer n to denote how many times you want to add it. But notice how the max, okay, so this is your x value, your radian measure, but the y value has a height of 3. Okay, that's where the amplitude's coming from. Now let's check out our mins. In this case, our first min is occurring at 3 pi over 4. But it looks like it takes us another pi units, 1, 2, 3, 4, which is the same thing as pi units in this case, to get to the next min. But in this case, the actual minimum value, the height, is -3. Alright, so let's try another one. This time let's check out cosine. We always want to start with the original. So cosine actually starts with a maximum, okay, that's 0, 1, and then it reaches an x-intercept, it goes down to -1, eventually reaches another x-intercept, and it's back at its max. Okay, wave motion. Notice how cosine, just like sine, is evenly spaced. So when we condense it or stretch it or shrink it, do whatever we do, everything's going to be evenly spaced, just like our original is. So let's see if we can identify what's going on here. Our A value is 2, so that means our amplitude is 2. And the period, we need to first identify the B value, which is 1/2. So we got to take the original period, which in this case is pi over 2. A full cycle takes, not pi over 2 pi radians, and we got to divide it by 1/2. But 2 pi divided by 1/2 is actually 4 pi. So our new period is going to have to stretch out all the way to 4 pi. We might have to extend our graph a little bit. And the frequency is just the reciprocal of the period, so we're going to have 1 over 4 pi. This is telling us one cycle is going to take 4 pi radians to complete it. Now the other thing that's going on in here, if you noticed it hopefully, is that we have a negative sign out front. So we got to be careful. We have a reflection. Remember, the amplitude is just the number itself. Negatives are always going to be reflections. So since our period is 4 pi and our graph really only goes out to 2 pi, let's take a second and go ahead and extend our graph. So this is this would be another pi over 4 after 2 pi, so we'll do 1, 2, 3, 4. So this would be 3 pi, and then 1, 2, 3, 4. We're left with 4 pi. Again, notice how 4 units is just another whole pi value. So another 4 units we'd have 2 pi, another 4 units we'd have 3 pi, another 4 units we would have 4 pi. So let's go ahead and go through our transformations. The first one is a reflection. Since we have that negative, we got to make sure we reflect our graph. So reflections just mean flipping it upside down. So let's flip our points. This max is now going to be a min. We can't really flip this one because it's already on that x-axis, but this min is now going to be a max. Again, we can't flip this one, but this max is now going to be a min. So there is our reflection. Let's go ahead and cross that off. Again, you can erase the original if you want to, because now we're only going to focus on the blue graph, but if you like your colors so you can see which one you're currently working on, go ahead and leave all your colors. So now let's try the period. The period is 4 pi. So again, instead of us ending on 2 pi, we need to stretch it all the way out to 4 pi. So we're going to be somewhere right there, and this one stays right where it is. And again, everything's going to be evenly spaced. So if we take a look at our blue graph right here, notice how we have a max right in the middle of our blue graph. So in between this red dot and this red dot, we need a max. And what's directly in between 0 and 4 pi is 2 pi. So our max should be right here. So again, if we look at our blue graph, okay, between this original blue dot that's been covered with red and the max, we had an x-intercept directly in the middle. So in between this red dot and this one, we need an x-intercept that's directly in the middle. In between 0 and 2 pi is pi, so we need an x-intercept right there. And the same thing going on this side. Okay, we had another x-intercept. So in between 2 pi and 4 pi is 3 pi. We need an x-intercept right in the middle. So again, connecting our graph, our dots, nice smooth wave, something like that. Hopefully yours is a little bit better than mine. Again, you can erase the blue graph if you want to, okay, because now we're really only going to focus on the red one. So let's cross off period. Now let's check out the amplitude. Okay, the amplitude is 2. So remember that baseline going right through the middle of your graph. Okay, it's still considered the x-axis now. We need to have a height or an amplitude of 2. So instead of this min having a height of 1, we now need to stretch it to 2. This x-intercept is going to stay the same because it's on the baseline already. This max, instead of having a height of 1, we need to stretch it to 2. This x-intercept is going to be the same. And this min has to have a height of 2. So instead of having a height of 1, we're going to stretch it down to 2. So let's go ahead and connect our green dots now. And there's our amplitude. Now we don't have anything moving up or down. There's nothing being added or subtracted on the end. So the green graph is our final cosine graph. Alright, so let's go ahead and check out our x-intercepts. Our first x-intercept is at pi, and it looks like from this x-intercept to the next one, it's over at 3 pi, so the difference between that, between pi and 3 pi is 2 pi. So we're going to have to add 2 pi n. Now let's take a look at our max as an ordered pair. Our max is occurring at 2 pi. But if we were to continue this, okay, we would go down here. So from 2 pi to 4 pi, we get to a min. But that means from 4 pi all the way over to 6 pi, we would have another max. Remember, this is going to keep going up, and this one's even going to go up in that case. So if our next max is going to be at 6 pi, the difference between 6 pi and 2 pi is 4 pi, actually, that period. So let's add 4 pi n, and the actual height is a value of 2. Now for the mins, our first min, it looks like 4 pi. And again, the next min is not going to happen for another whole period, another whole 4 pi. So let's add 4 pi n, and the min is actually at -2. Alright, let's go ahead and try another one, but this time we're going to throw in a translation. Notice how we have a +1 on the end. So this guy right here, if we remember our translations, is going to move our graph up 1. So that's a little note for us. We actually are going to have this last step to do. Let's go ahead and identify our amplitude. Our A value is 2. And our period is 2 pi over 1/2, okay, over that B value, but 2 pi divided by 1/2 is 4 pi. So our new period has to go out to 4 pi. Let's see if we need to add anything on our graph. So 4 units is still pi. If we go another 4 units, that's 2 pi. If we go another 4 units, so this guy right here is 3 pi. It looks like we gotta go a little bit more off our graph. So we have 1, 2, 3, 4. Here's 4 pi right there. Alright, so let's go ahead and start with the original. So sine starts at the origin, then it goes to a max of 1, x-intercept, min of -1, and then back at the x-intercept, there's 1 full period. Alright, so do we have a reflection? Do we have a negative in front of that amplitude? No, we don't, so we don't have to worry about that. Our period is 4 pi, so we're going to always start at the origin, but this ending point has to be stretched all the way out to 4 pi, because instead of taking 2 pi to do one whole cycle, now it's going to take us 4 pi to do one whole cycle. But remember, everything is evenly spaced. So in between these two dots, we need an x-intercept, just like we had there. So in between 0 and 4 pi is 2 pi. There's our new x-intercept. And we need a height of 1, a max of 1 in between our beginning point and our middle point. So in between 0 and 2 pi is pi. We can have a height of 1. And then we need a min of -1 in between 2 pi and 4 pi, so that's 3 pi, somewhere right there. So notice how we're stretching our graph, and this time one whole cycle is taking 4 pi instead of 2 pi. So let's cross off the period. Now let's check out the amplitude. Okay, so amplitude, we have a new height of 2. So from our baseline, the middle of our graph, instead of having a height of 1, we got to go up to 2. And same thing here, instead of having a height of 1, we got to go down to 2. So we're going to connect our dots. So we'll cross off our amplitude. Again, you can erase these as you go. Notice how we didn't really need the black graph to do the red one. So you can erase each step as you go, or again, if you prefer the colors to see each transformation, you can leave them on there. But last but not least, we have this other piece. We're adding 1 on the end. So that is an up motion. So all of these red dots we need to move up 1. So this guy is going to move right there. This one's going to move up 1. This one goes up 1. This one goes up 1. And so would this one. So connecting our dots. There's our new graph. And notice how when we move it up, we're actually moving the baseline as well. Okay, so originally our baseline was that x-axis, but since we moved it up, okay, now we have a new baseline. It's actually at a value of 1. Notice how that's right in the middle of our graph, because this height right here should be an amplitude of 2, which it is, and this height right here should be an amplitude of 2, which it is. So since we're moving it up 1, the baseline moves as well. So we can cross that last one off our list, which means the green one is our final graph. Alright, last but not least, let's go ahead and try our last one. Kind of a doozy because it basically has all of these in it. So let's kind of rewrite this first. Notice how they have a +3 written first. Normally we're used to seeing that on the end, just like how this was a +1 on the end. So let's go ahead and rewrite this as y equals -4 cosine of 2x and then we'll put the plus 3 on the end. That might be a little bit easier for us to identify the different pieces. So since we have a negative, okay, that's cluing us into a reflection. The amplitude is 4. The period, we have 2 pi over 2. Okay, so we're looking at this guy right there, 2 pi over 2, which means our new period is pi. And this guy, we're moving it up 3. So let's go ahead and start with our original. Cosine starts with a max. 2 pi, we have that x-intercept. Pi, we have a min. And the pattern continues in that wave sinusoid motion. So there's one period. Let's take a look at the reflection. So just flipping our points, a max becomes a min becomes a max, and a max becomes a min. So there's our reflection. So now let's check out the period. Okay, it should only take pi radians now to do one full cycle instead of 2 pi. So keeping our original point, we got to shrink this one down to pi, which would be right here. And notice how on our blue graph, right in the middle of our 2 points on the bottom, we had a max. So in between these 2 red points, we need a max, which would be somewhere right there at pi over 2. Which means in between those 2 points, we need an x-intercept, and the same thing here. So wave motion, there is our period. Notice how one full cycle only takes us pi units, or pi radians. Alright, now let's check out the amplitude. So when you got to do an amplitude of 4, instead of having a height of 1, we got to stretch it to 4. So somewhere right there. Instead of this guy having a height of 1, we got to stretch it to 4. And same with this guy, instead of a height of 1, stretch it to 4. So the x-intercepts are going to stay the same. We're just stretching our graph vertically. Alright, so there's our amplitude. And last but not least, we got to move all of our points up 3. So I'm kind of running out of colors. I wonder if I can get a... Ooh, let's try orange. Okay, so moving all of our points up 3. We have 1, 2, 3. Probably not the best color choice, I guess. And then up 3 units, 1, 2, 3. 1, 2, 3. 1, 2, 3. And lastly, 1, 2, 3. So if we connect the orange ones, there's our graph. Now, since we still have more room on our graph, I do want us to fill in the extra waves. So this pattern, this cycle, is going to repeat itself. So if we were to continue the process, we'd have another point here, and then a max, another one there, and then a min. And we repeat another full cycle going through the wave again. There we go. And we'll connect the dots. And we can even go in the other direction. If the pattern were to continue the other way, it looks something like this. So there is our final graph of this cosine function. Again, notice how if we're moving our graph up 3, the baseline is moving with it. Okay, the middle of our graph is right there. Right through the middle. And notice how that has a height of 3. And again, take a look at your amplitude. From the baseline to the max is a height of 4. And from the baseline to, I'll go over here, to the min is a height of 4. So everything's checking out just like how we anticipated it to do from our original equation. So good luck on the practice and the application and that mastery check without that graphing calculator. And I'll see you guys later.